atoms or compounds are given energy in the form of heat, for example, the electrons get excited and jump from one energy level to another. That is, they obtain more energy and momentarily move to a higher energy level. This is known as the excited state. But as this is only temporary, the electrons will naturally return to their original level. This is known as the ground state. Focusing on one electron at a particular energy level, when energy is applied, this electron will jump to another energy level. It can be more than one, but as it's only temporary, it will return to its ground state, and the amount of energy required to reach that excited state is proportional to the amount of energy released when it returns. It may not fall back in one go either. If it had jumped, say, 2 energy levels, it may fall back one level, then a short time later the second energy level. So there may well be two different frequencies of light emitted. And since energy in the form of light changes with frequency, big jumps in energy release UV light, medium jumps release visible light, that is different colors, and small jumps release infrared radiation. The energy release is unique to each element. This relationship is described by the equation given, where delta E is a change in energy, h is Planck's constant, c is the velocity of light, and wavelength refers to the visible light, UV or infrared radiation emitted. So logically, if hc equals 10 and wavelength equals 10, then delta E equals 1. But if hc equals 10 and wavelength equals 2, as in it has a shorter wavelength, then delta E equals 5. That is, more energy is emitted with light that possess shorter wavelengths. So when an electron jumps from one energy level to a lower one, energy of a specific frequency, or I guess wavelength, is emitted. If this is within the visible spectrum, we will detect it as a certain color. And this is unique to each element, as they all emit different frequencies of light when excited.